Thank you. So welcome. Today we're going to be talking about window functions um, and how to use them and what else they're good for. So there are a couple of pure window functions that we'll see, and then there are a number of other things that can be used on the same windows that we'll also see. So first of all, why me? And the answer to that is why not? You can do this too. In fact, I encourage you to do this. Think of a subject that you know well and give a presentation. It's just that easy. I've been involved with Postgres since 2008, and since 2022, I've been on the SQL Standards Committee. So for the sample data, we're going to be using Robert's PGDay database, which this is the first time I've given this talk with him in the audience, but it's a sample database of a movie rental store, which is kind of dated now, but it still works as data. So the sample data that we're going to be working on is, first of all, we're going to see a portion of the customers so that it fits on the screen. And so here I'm selecting the store ID, first name, last name of the customers whose name starts with W or higher. And I'm going to order that by first name and last name. And that looks like this. So no big surprise here. This is nothing complicated. This is just the people whose first name starts with W or higher in the alphabet, in the Latin alphabet. So first some concepts so that we're all on the same page. A row is a sequence of one or more values, and the number of values in the row is called the row's degree. We won't use all of these concepts, but it's just so that we're talking about the same thing. A table is a collection of 0 or more rows, and the number of rows in a table is the table's cardinality. A base table is a table that's persistent. So this is a table that you get when you do create table, for example. A derived table is what you get a derived table is the result of a query. It's also a table, it's also a collection of rows, but it's not stored anywhere. You can also name derived tables and call them views, or you can just use subqueries, or even not a subquery. A regular query is a derived table. A group table is a derived table that has groups according to the group by clause. I am supposing you all know what the group by clause is. If not, please do ask questions. I can explain as we go. And when we group a table, a derived table, into a group table, we use aggregates to collect the data into single rows. And then a windowed table, which is what we're going to be talking about now, is a table over which we have windows defined. And what is a window that's defined over a table? Well, that's the entire point of this talk. So we'll start out with window specifications. And the simplest one that we can have is just nothing. So we have a window clause in the query, and I named here a window called W, and it's a window over everything. There's no options, it's just a window. And so this defines a window as being, the window W as being over the entire result set of the query. Now, to use a window, we need a window function, and the most basic of all window functions is row number. All this does is it assigns a number from 1 to however many rows there are in the result set, and outputs that. So here we have the same query as before, except now we have the window W as empty parentheses, and we have a row number over that window. What do you think the result's going to look like? Okay, it looks like that. Why does it look like this? It is a sequence, 1, 2, 3, 4, 5, but it's not It's not in any order. And that's because the window has an order on its own, and you use that as an order by in the window specification. And that order by, sorry? Yeah. That order by is independent of the global order by that you have for your query. So here, I'm ordering by first name in the window, and then by first name, last name outside of the window. And now we get what we would expect. Except there's something a little fishy going on here. Sorry? They are kind of sorted. Here, we go 10, 12, 11, 13. Why would we go 10, 12, 11, 13 here? Right. So what I did here in the query is, for the window, I ordered by first name only. And I have two Willies. And so the order of those two Willies is not defined. We don't know what it is because we only ordered by first name. Although in the rest of the query, I ordered by first name and last name. So if we wanted this to be perfectly ordered, what should we do? Right, we could put the last name in the order by of the query, of the window specification. But what if we don't have something like that? Then what we would do is we would not use row number, we would use one of two different functions called rank and dense rank. And what these do is they give numbers to, they give the same number to peers. And so if we look at this, now we see that for rank and dense rank, both Willies have an 11. And the way I like to explain this is like the Olympics. The Olympic Games, when they have three winners, gold, silver, and bronze. But if somebody ties for gold, they give two golds, but the bronze person doesn't get silver, they get bronze, right? So that's what the rank is. You see the 11s, both Willies are tied, so they both get 11, and then in the rank, we skip 12 and go straight to 13. In the dense rank, we just start with 12. Both Willies still get 11, but then we start with 12. So it depends on what use case you have. Yes?
So dense rank gets the silver?
Yes, dense rank would give bronze, the third place winner would give them silver, and would bring up a fourth place to have bronze. The normal rank will just skip 12 because, right. There are two more that I don't go into too much detail because I've personally never used them, but there's a percent rank which shows where the row sits between 0 and 1 as a percentage of where it sits, and cumudist, which is the cumulative statistical distribution, which is the fraction also between 0 and 1, the fraction of rows that come before this row. And we'll see what this row means in a minute, but those two ranks also exist. So window partitions. If we looked at the beginning of our sample data, we had all the customers whose first name starts with W or higher, but they go to different stores. I'll show that in the next slide. They go to different stores, and if we want to separate all of our statistics and our analysis based on which store they're going to, then we can partition the result set by store. And so that happens here by putting a partition by in the window specification. Okay? This is kind of like a group by, except it doesn't collapse any rows. It just partitions them. And so now we get this. Our same query with the row number, rank, and dense rank. But now we see that store 1 goes 1, 2, 3, 4, 5, and store 2 also goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can still see that Willie Howell and Willie Markham are inversed in in the row number case. And this is actually an artifact of how Robert has built this repository, because what it's doing is it's taking it in physical order, and not in any order that we specified. But that's why the tuples are switched. But they remain switched because Postgres still reads in the same order. Any questions on this? No, okay. So lag and lead are two other window functions that we can use to look back in the result set of a query or a derived table, or to look forward. So lag will look back, and lead will look forward. So here what I'm doing, and this example is kind of contrived. No, I don't think anybody would actually do this in a real dashboard for their statistics. But what I'm looking at here is the same data, and then I want a row that has the last name of the previous row, according to the order by, and a row that has the last name of the next row, according to the order by. And so that one looks like this. So I will let you look at this just to verify what I'm talking about, but you can see that del val is the previous row, and height is from the next row in the first partition. If you go beyond partitions, then you get nulls. And that's what I've done with the little crosshatch, is I'm showing that these values are null because there is nobody before deval, and there is nobody after height in the partition. And same thing for Perryman and Watkins in the second partition. So these two functions both take multiple parameters. The first argument is the value, the column reference, or any expression of the previous row that you want for lag, and of the next row for lead. The second extra argument is offset. So if you don't add it, the default is 1, so it just goes back one row. But if you want to see what the last name was of the person 3 rows behind or before in the result set, then you would do lag last name, comma 3. And then the second one, which is the second optional argument, which is the third total argument, is the default value. And this is used for when we fall off the end of the partition. So here, I didn't, in this query here, I didn't put any offset or default value. And so it's 1 and null. And so as you see, I get nulls here from the previous or the next thing. We can also say ignore nulls on these. Oops, I'm on the wrong slide. Right. We can also say we want to respect nulls or we want to ignore nulls. And so what this means is that if we just do a regular lag, it'll go to the previous row. But if the value that we're looking for at that row is null, and we say ignore nulls, it will go to the next previous one and keep going until it finds a row that's not null, and that will be our lag 1, or lag whatever we put in the second argument. Now, this slide used to have green and red because Postgres would always respect nulls. It only knew how to go back a certain number of rows. And it didn't accept the respect null syntax. It just gave that behavior, which is the default behavior. And it didn't accept ignore nulls and didn't have that behavior at all either. Version 19 of Postgres will change that. And now we will be able to do respect nulls and ignore nulls on window functions. 19. Yes. All right. The next window function I wanted to present is endtile. And this function allows us to split up the partition to evenly sized quantiles. So what I'm doing here with endtile 5 is I'm saying put everybody into 5 different buckets. Okay? And I'll just show the result. For store 1, because we still have partition by store ID, so we're still partitioning by store. So for store 1, we only have 5 people in it. And so we get 1, 2, 3, 4, 5. In store 2, we have 11 people, I think. I didn't recount, but, and that's not divisible by 5. And so we've got 3 in the first bucket, and then 2 in the second bucket, and then 2 in the third and fourth bucket, but it looks weird because the willies are still causing problems here, and then 2 in the fifth bucket. So if there were a 12th row, it would go into bucket 2, and a 13th row would go into bucket 3, and so on. So it divides it into buckets of 5 people, because I said entile 5. If I wanted 6, I'd put 6. So, yes, question? It's 5 buckets. So there will, in this example, there will never be fewer than 1 and never be more than 5. And how many people are in that depends on how many people you have. But it's not assigning them 5 people per bucket. It's 5 buckets for all the people. So we've seen a number of window functions that work on an entire window table, and also that can be divided by partitions. We saw in the lag and lead that we get nulls if we break partitions. We can never ever cross partitions. It's just not possible. If we put a partition by in the query in the window specification, everything we do is going to be limited to that one partition. Well, for each partition. But we can go beyond that with window frames. Now, a window frame is only valid, it only makes sense if the window is ordered. Sorry, it doesn't have to be partitioned. If it's not partitioned, the entire result set is one big partition. But it does have to have an ordering, because the functions that work on this don't make any sense without an order. So these are required. And I'm changing our data set just a little bit. For this one, again, there are no windows here. This is just to show you what the data we're going to be working with is. I've chosen customer 318 because there are few enough that it fits on the slide. And so here we just have the customer ID, which is always going to be 318. We've got the payment date, which varies, a rental ID, and an amount. Nothing too spectacular here, but this is what the data we're going to work with. And so to define our first window frame, it gets kind of verbose because SQL likes to have lots of words. And so this one is basically the same thing as we had before. It's partitioning by customer ID, it's ordering by payment date, and it's taking all the rows between unbounded preceding, which means from the beginning, to unbounded following, which means all the way at the end. So 2 new window functions that we can use are first value and last value. And this will take the first value of it'll take the value that we ask for, so in this case, rental ID. It'll take that value from the first row in the window frame. And to make this a little bit more interesting, instead of just the first and last row of the entire partition like we've been doing, here I'm limiting to just 7 rows. So we're taking 3 rows preceding the current row, and then 3 rows following. So that's 7 total. And that, with a little bit of color to help you see it, looks like this. So as Postgres goes through all the rows, each row will become the current row. And then for our first value and last value, it will look at the 3 rows preceding whichever row it's working on right now, up to 3 rows, because at the beginning there aren't, and up to 3 rows after the row that it's working on. And so here I've highlighted 1 row, but you can, so that you can see that the first value of 3,974 is actually the first value of the window frame that we're looking at here, the light yellow. Do the colors come across for you? Yeah, okay. And 7,853 is indeed the last rental ID in this frame of 3 rows preceding and 3 rows following. And then you can look for yourself on a different row that the first and last are moving. So we've got this whole window frame that is moving across the window, and it will never pass a partition. So first value and last value also ignore nulls. We don't have any in this example, but if we were to say, I want the last value in this window frame, ignore nulls, then it would start at the bottom of the window frame, and then it would creep back up until it found a value that is not null. And this will allow us, I should put an example in, but this will allow us to fill in the blanks. So if we have sparse data, where something happened here, here, and here, we can use last value, ignore nulls to fill all that in. First value and last value are special cases of nth value. And so this one takes an expression of what you want to calculate at which offset. And you can start that from the beginning of the window frame or from the end of the window frame going backwards. And you can also say respect and ignore nulls. So first value is basically equivalent to nth value of the expression, comma 1 from first, and last value is the nth value of the expression, comma 1 from last. Okay? But in order to not have to type all that every time, first value and last value are easy shortcuts for that. So one thing to notice about this is that there is no default value if the offset falls off the frame. So in our example where we have three rows preceding and 3 rows following, if we did nth value 20 from first, we would get a null. And there's no way to make a default value for we went past the window frame. So those are 3 window functions that work over window frames. Do you have any questions about framing? Yes, Robert?
So when you do the ignore null case,
yeah.
So if there are no non-null values, so return null.
Yes. Yes. So in case you didn't hear, the question was, if you do ignore nulls on first value, last value, nth value, lead or lag, and everything in the column is null, lead and lag will return your default. First value, last value, and nth value will return null. I'm sorry, no, that's not true. Yeah, it is true. It is true. Lag will return your default because it fell off the partition. Okay. Next is aggregates over window frames. So this one is really cool, and this is where the Windows really shines, is because you can take any aggregate that you want and just put it in the over clause, and it will do that over the frame. So here's an example of running totals. So in here, I'm just using a normal sum aggregate that I believe everybody knows. Just add up all the values of amount. But I'm saying over the window called W. And in the window called W, I've defined that as partition by customer ID, even though we only have one, so that it's kind of cheating. Order by the payment date. And then I want all of the rows from the beginning of the frame, from not the beginning of the frame. The frame is from the beginning of the partition to the current row. And I want to sum all that. So that'll give me a running total of values, like this, right? So the first one is 799, so the running total is 799. The second one is 299, so the total is 1098, and so on. So for this one, I'm going to switch to a different customer. I'm doing customer 63. The rest of the data is the same, but this one has something that'll be interesting to see. So I'm switching to customer 63, and I want to do this by date instead of by timestamp, because in my financial report, I don't actually care what time the person made the payment. I care what day they made it on. And so here, I'm doing an order by cast payment date as date. So that's poorly named. It should be payment timestamp, but it's called payment date, even though it is a timestamp. But I'm taking off the time. I want everything by date. And so this gives us the exact same thing, except now in payment date, we can see that there's no time component, so it's just dates going all through. Do you notice anything interesting about this example? Because this is why I changed to customer 63. What's happening here? I have two rows with the same date, March 11th, 2007, but my running total is different. So which one is correct? Was the running total up until that date 40.94, or was it 41.93? It's inconsistent, and we don't know. So the way to fix that is very simple. Instead of saying, so in this query I have rows between unbounded preceding and current row, instead of saying that, I just changed one word. I changed rows to range. And this one will now look forward for any what's called a peer row. Okay, so it will look for any rows according to the order by that match, even though we're telling it between unbounded preceding and current row, it's still going to look past that current row to find anything that's the same as the current row. And so now, for both rows, we get 4193. And now our report is coherent. Self-consistent is the word I was looking for. So let's get even more advanced and do rolling averages. This happens a lot in financial reports where we want to know what the average sales were for over 3 days or over 7 days. And just for fun, in this presentation, we're going to do all of them at the same time. So what I'm going to do here is because payment date is a timestamp and I want everything by date, I'm going to simplify the queries in the presentation. This doesn't work in actual SQL, but in the presentation, I'm going to say payment as date is equal to, by definition, cast payment date as date. Okay, so when you see payment as date, it's this cast. I just wanted to save some space on the slides. So here we have a rolling average of, should be average, not sum. Sorry, this is a mistake on my slide. So it's the average amount, not the sum amount, of the payments. And I'm doing an offset 10, fetch next 15 rows only, because I want 15 rows in the example, because that fits nicely on the slide. But I also want the averages to be realistic. And so averages at the beginning of the window frame are kind of compressed because there's nothing, there aren't 7 days before to figure it out. So I'm just moving ahead 10 days and then showing you 15 from that. And I've decided to remove a couple days so that you can see different averages. So this is our sample data for the rolling averages. Because as you see here, there are no windows or anything. This is just showing you what the data we're working on is. So this is our derived table. And you can see that between the 7th and the 15th, there's only the 11th because the query excluded those other two rows, the dates in between. So now what I'm doing is I'm defining two different windows. One is called W3 and one is called W7 for window over 3 days and window over 7 days. And so I'm ordering by payment as date, which is the cast from timestamp to date. And in W3, I'm saying I want the range between 3 days preceding and current row. So I want the average of, even though it still says sum, I want the average of 3 3 days before, but I don't know how many rows that is. I don't care how many rows that is. I just want 3 days. And for W7, I want 7 days for my average, and I don't care how many rows that is. It could be 200 rows, it could be none. And so here's an example of that, where you've got the 3-day average and the 7-day average, and because I removed days around the 11th of December, 2006, you can see yes, you can see that the amount, which was 66.85, so I was actually correct here. It is the sum, but we're putting the average on top of an actual sum. So this is using window functions over a grouped table. So the sum amount is all of the payments of that day. So that was correct. I'm sorry, I misled you before. We have all the payments of the day as the sum amount, and then we're averaging those sums. So you've got a window function over an aggregate function. And in the results, you see that on the 11th, the amount of sales on that day was 66.85, and the 3-day average is also 66.85 because there are no other rows there. So unlike what we did before, we just went 3 rows back, rows between 3 preceding and current row. Here we're doing 3 days, and because there aren't 3 days before the 11th average stays the same. I hope that was clear. So extensions and abbreviations, which is how we can simplify that query. So here's the query again, just to show you, and there's a lot to read here. And so we'd like to reduce this because one, if we decide that we don't want to order by payment as date, we want to order by something else, we have to change it twice. And range between 3 days preceding and current row is kind of long-winded. It's a lot to type and a lot to read when you're studying this. And so we can do extensions. So here, I've taken, the first block is what we just did. That's W3 and W7. And what I've done is I've extracted the order by out of it and made a window W, which is just the order by. And then W3 and W7 extend that window specification by adding a frame on it. So you see there's a W at the beginning, all right? And then here, if your last row is current row, you can you can abbreviate that to just how many preceding you want. And so range between 3 days preceding and current row becomes just range 3 days preceding, which is a lot easier. And now the query looks like this, which to me is very concise and very easy to read. For me, maybe it is for you too. And if I want to change the ordering, I just have to do it on W. There's nothing in my query that uses W. That's just a basis for extending into W3 and W7. Any questions? Yes?
How long have we supported extension?
Forever. So 8.4, when the functions were introduced. So 8.4 was 2010 or 2009. Yes, Bruce.
It's not an extension to the standard, it's just an extension of macros.
Right, it's extending the window specification. And this, okay, sorry, I will repeat both questions. The first one was how long have we supported extensions? And that was, I believe, since 8.4 when window functions were introduced in 2009. And the second question was, it's not an extension to the standard, it's an extension, we're extending a previous window specification. So what I called here extensions, yes, it's not, the standard has these. This is standard SQL. And while writing this, since I like to put my SQL keywords in capital letters, I realized that standard SQL has no way to round anything. So that's why those are lowercase. Because that's not that's a Postgres function, not an SQL function. But yes, apart from the round function, all of this is standard SQL. Question? Oh, okay. Okay. So the next frame mode, so we've seen rows and we've seen range. There's also groups. And this one is a little bit more complicated to explain. This one we've only implemented since recently. I don't remember which version of Postgres added the groups, but it wasn't in the original implementation of 8.4. It's a little bit harder to explain, but basically it takes all peer rows and groups them together. And so when you say what did I say here? One proceeding, it's one of those groups of them. An example is better, so we'll just look at an example right now. I'm ordering by length of the film, and I'm taking the group between one preceding and one following. So there are only two groups on this slide because I don't have room for more. I could have filtered a little bit more, but that would have complicated the query. But what we see here is that the neighborhood average is 2.66 because all of the films of length 46 are grouped together, and then all of the films of length 47 are grouped together. And that's how it's taking that average. We have frame exclusions also. And fun fact, Postgres was the first implementation to completely implement the Windows specification with exclusions and groups. Others do it now, but Postgres was the first. So when you're calculating something, you can exclude a row, or you can exclude nothing, which is exclude no others for some reason, and that's what we've been using the whole time. You can exclude the current row, so we're saying I would like to analyze rows around this row, but I don't want this row to be included. You can exclude a group, which I'll show an example of, and you can exclude ties, which is the same as peers. It's kind of the range thing for this. So for excluding one row, you add that after your thing. And so here, I'm calculating the average rental rate of a film ordered by its length and grouping into the length of one preceding, one following, but not using the current row. So that looks like this, where now the others in neighborhood are all strange because they're calculating that average without the current row. It's very powerful stuff. And unfortunately, I haven't seen any of this in the wild of people actually using this, but most of the experience that I have is people doing OLTP, and this is OLAP functionality. So we can exclude the whole group also. So here again, we're on Alien Center as the current row, and we're just getting rid of everything in the group. Like we don't want anything with length 46 to come into our average. So here we're averaging whatever came before 46, which might be 45 or it might be 30. We don't know because it's not in the data supplied. But the query is groups between one preceding and one following. So the current row on Alien Center is between whatever the earlier length is and 47. It's averaging those, but excluding all of the films of length 46. So, two things that are not in Postgres and so are not in this presentation is row pattern matching, which is basically defining your window frame based on regular expressions. And it's very powerful stuff. We don't have it yet, but Tatsuo Ishii is working on it. And it might be mature enough to be in Postgres 20. I don't think it made the cut for 19. but there is active development on row pattern matching for window functions. And there are also nested window functions, which are kind of interesting. In a windowed aggregate, you can reference anywhere in the window frame that you want. It's a little bit more complicated. I don't talk about it here because Postgres doesn't have it. But it's there, and you can please come talk to me in the hallway, and I'll explain all about it if you want. We all know that Postgres is very extensible in the sense that you can create your own functions, your own aggregates. It's hard to create your own window functions. You have to do it through C. There's no syntax in create function to do it, so you have to use the internals. It's very difficult, but if you want to see what it looks like, I've written an extension in the Postgres sense, so create extension, for extra window functions for Postgres. I need to update this because one of the type of functions that I have in this repository is ignoring nulls. And now Postgres has it. So when I update this for Postgres 19, I'm just going to remove those functions, and my extension will become a little simpler. But I also have a fun one in there that I invite you to go take a look at. And thank you.